Yesterday, Google and Tel Aviv University published a paper that put game devs and AI doomers on life support. What you're looking at right now is not gameplay from John Carmack's 1993 classic first-person shooter, Doom. It's actually a brand new game from 2024 powered by Game Engine, the world's first entirely neural network-based game engine. The environment, the collisions, and the graphics are all simulated in real time at 20 frames per second, and not a single line of code was written to develop this level. Back in March, Jensen Huang predicted that most video game graphics could be generated by AI in real time within 5 to 10 years. If he's right, when GTA 7 comes out in 2042, just imagine being able to run over billions of unique NPCs across multiple parallel universes.
Sorry about that.
In today's video, we'll find out how this black magic actually works and whether or not it's the future of game development. It is August 29th, 2024, and you're watching The Code Report. Before we can understand how Game Engine works, we must first understand Doom, a game that was revolutionary when it came out in 1993. Not only was it a violent game that moms hated, but it was a huge technical achievement in 3D gameplay. While the player runs around obliterating demons from a 3D perspective, the enemies and objects are actually just 2D sprites rendered at fixed angles. This differs from modern games that use billions of triangles and linear algebra to render 3D objects. The key takeaway here, though, is that Doom is not a true 3D game, and its underlying technique is often called 2.5D graphics or billboarding. In other words, you take a bunch of 2D images, but skew and scale them in ways that make it look like a 3D environment. It's genius, so let's take a moment of respect for its lead developer and legendary programmer, John Carmack. Not only did he create Doom and Wolfenstein and Quake, but he open sourced the Doom engine in 1997, which inspired an entire generation of new programmers. Currently, he's working on artificial general intelligence at Keen Technologies, and let's hope he gets there before Sam Altman does. But now that you understand how Doom is just a bunch of 2D sprites, Game Engine becomes a little less magical, which is based on Stable Diffusion. It relies on an augmented version of Stable Diffusion 1.4, which is trained to predict the next frame based on the sequence of past frames and actions. And the other big component of the architecture is a reinforcement learning agent, which is trained to play the game and record itself like an artificial Twitch streamer. Google has taken a lot of L's recently, but it's also been shipping some amazing tech, especially when it combines reinforcement learning with generative AI. Like AlphaCoder uses a similar technique to beat virtually all competitive programmers, and AlphaProof can beat almost all math Olympiads. But when it comes to the game engine, their biggest challenge was addressing autoregressive drift, where the quality of gameplay starts to decrease over longer sequences. The model only has a limited context window of about 3 seconds or 60 frames, but in a fast-paced game like Doom, that's all you need for real-time gameplay. And despite the small context, it does keep track of health and ammo based on the actions taken by the player. The big question, though, is does this make game developers obsolete? The answer, of course, is no. This game is barely playable, and the tech has no practical application for the time being, but in the not-so-distant future, you could imagine a developer like Rockstar Games using an RL agent to play the GTA world, combined with some futuristic generative 3D model that can spit out new terrain, NPCs, and even storylines on the fly. But you really shouldn't be playing video games because women find it the most unattractive hobby for men. The real world-changing application of technology like this is going to come in robotics. Real-time environment simulation will allow robots to train rapidly without physical hardware. Like when it comes to capital punishment, it's extremely hard to gather enough data for a large model. Well, not anymore, thanks to Google's Project Talon.
The new device is designed to be as humane as possible, emitting soothing white noise and putting prisoners on a cushioned seat before its metallic talons dig into their necks and painlessly wrench their heads off.
The Figure 2 robot was just released a few weeks ago. Elon is building Optimus robots. NVIDIA recently unveiled Project Groot. Google's investing heavily in robotics research, and they're all trying to make Terminator-like humanoid robots a thing. And if they succeed, we'll have to put yet another dollar in the Arthur C. Clarke was right jar.
The future does belong to the robots. Biological evolution has about come to its end. They will start to think, and eventually they will completely outthink their makers. Is this depressing?
Yep, this has been The Code Report. Thanks for watching, and I will see you in the next one.